Welcome to another deep dive into the world of psychedelics. This time, we're taking a closer look at the safety side of things.
Yeah, and it's a good thing we are too, because we've got some really interesting stuff to dig into.
We do. I especially want to focus on the risks, like serotonin syndrome and neurotoxicity, especially since we're seeing more and more interest in psychedelic therapy these days.
Right, and with the rise of psychedelic therapy comes the responsibility to really understand how to use these substances safely and responsibly.
Exactly. And speaking of responsible use, we've got some super detailed info to work with today,
Yeah.
like this investigator's brochure from MAPS all about MDMA.
Oh yeah, that's a fantastic resource.
Right.
It really gets into the nitty-gritty of MDMA's effects and the precautions that need to be taken in a clinical setting.
So should we just jump right in?
Let's do it.
All right, well, first off, let's talk about this whole serotonin syndrome thing. It sounds pretty scary, but I'm guessing it's not as common with psychedelics as some people might think.
You're right about that. The classic psychedelics like LSD and psilocybin, they don't really cause a massive surge in serotonin levels the way some medications do.
Okay, so that's good to know. But then how do they work? What's their main mechanism of action?
Well, their main action is on specific serotonin receptors,
Yeah.
particularly the 5-HT2A receptor, which seems to be the star of the show when it comes to psychedelics.
Ah, the famous 5-HT2A receptor.
Yeah.
Seems like that one pops up everywhere in psychedelic research.
It does. It plays a crucial role in the subjective effects that people experience, the altered perceptions, the mystical experiences.
Right, but it's also been linked to potential risks, right?
Yeah.
Like the neurotoxicity we were talking about.
That's right. Especially with MDMA, the 5-HT2A receptor is thought to be involved in the potential for neurotoxicity.
So how does that work? Like, walk me through the whole process. How does messing with this receptor lead to potential problems?
Sure. So when MDMA binds to the 5-HT2A receptor, it triggers a chain reaction. It starts with neuronal excitation, which is basically revving up the activity of brain cells, making them fire more rapidly.
So it's kind of like putting those neurons into overdrive.
Exactly. But here's the catch. It also triggers the release of another neurotransmitter called glutamate.
Oh, glutamate. Isn't that involved in learning and memory? I vaguely remember something about it from my college psych class.
You got it. Glutamate is actually the most abundant neurotransmitter in the brain. It plays a crucial role in all sorts of cognitive functions. But too much glutamate can be a problem.
How so?
Well, imagine it like an electrical overload in the brain. It can actually damage those neurons, leading to what we call excitotoxicity.
Ah, okay. So MDMA, through the 5-HT2A receptor, leads to an excess of glutamate, and that's where the potential for neurotoxicity comes in.
Exactly. And some researchers believe that this cascade, triggered by 5-HT2A activation, is one of the central mechanisms behind MDMA's potential to cause neurotoxicity.
Wow, that's pretty intense. So if someone is considering MDMA therapy, what are the practical implications of all this? Like, what can be done to minimize those risks?
Well, that's where this MAPS brochure you mentioned comes in handy.
Right.
It outlines specific strategies for mitigating these risks in a controlled clinical setting.
Like what?
For example, close monitoring of body temperature is absolutely crucial because MDMA can interfere with the body's natural thermostat.
So it's not just about the drug itself, it's about the entire context of how it's administered and monitored.
Exactly. And of course, careful patient screening is essential. You wouldn't want to give MDMA to someone with pre-existing cardiovascular issues or someone who's taking medications that could interact with MDMA.
Oh, that's right, drug interactions. I remember seeing something in here about liver enzymes. Can you break that down for me?
Sure. So MDMA is metabolized by certain enzymes in the liver. One of the key players is CYP2D6.
CYP2D6, got it. So how does that relate to potential drug interactions?
Well, you can think of CYP2D6 as a sort of cleanup crew in your liver. It breaks down MDMA and gets it out of your system. But if someone is taking a medication that inhibits CYP2D6, it can slow down that breakdown process.
So the MDMA stays in their system longer.
Exactly. And that could potentially lead to a higher concentration of MDMA in the body, increasing the risk of those effects we talked about earlier, like the changes in body temperature and cardiovascular strain.
Got it. So even seemingly unrelated medications can really mess with how the body handles MDMA.
They can, and this is why a thorough medical history and careful medication management are so important in any therapeutic context involving MDMA.
Okay, we've talked a lot about MDMA. What about some of the other psychedelics like LSD and psilocybin? Do they have similar safety concerns?
Well, they each have their own unique profiles. LSD and psilocybin, for example, don't have the same impact on body temperature or cardiovascular function as MDMA does.
Okay, but there are other things to consider, right? Especially when it comes to psychological safety.
Exactly. You're thinking about set and setting.
Yeah, that's the term I was trying to remember. I've heard that it's super important in psychedelic therapy.
It really is. And it makes sense when you think about it. These substances can bring up some heavy stuff, challenging emotions, buried memories, all kinds of things.
I can only imagine.
So having the right mindset going into the experience and being in a safe and supportive environment can make a huge difference. It can even influence the therapeutic outcome.
So it's not just about the drug, it's about the entire context of the experience.
Exactly. And we can dive into the nuances of set and setting and how they relate to safety a little later on.
Sounds good.
But for now, why don't we shift our focus to some fascinating research on LSD and how it interacts with the brain?
Okay, let's do it. So you were about to tell me about some interesting research on LSD and how it interacts with the brain.
Right. One study that I came across looked at LSD's effects on the brain using these pretty fancy imaging techniques, fMRI and MEG.
Oh, wow. Those are some high-tech brain scans. What did they find?
Well, they found that LSD actually decreases activity in a particular brain network called the default mode network.
The default mode network. Okay. I think I've heard of that before, but can you remind me what that is exactly?
Sure. Think of it like your brain's autopilot mode. It's the network that's active when you're kind of spacing out, daydreaming, or lost in your own thoughts.
Oh, right. So it's like when you're just kind of zoned out, not really focused on anything specific.
Exactly. And it's also involved in our sense of self, that feeling of being a separate me, distinct from the rest of the world.
I see. So how does LSD affect this default mode network?
Well, the researchers found that when people took LSD, the activity in this network decreased. And this decrease in activity correlated with something pretty interesting experiences of ego dissolution.
Ego dissolution. What's that?
It's basically that feeling of the boundaries between yourself and the world kind of dissolving or blurring. People often describe it as a sense of oneness or interconnectedness.
So it's like that feeling of losing your sense of self, merging with everything around you.
Exactly. And it's thought to be one of the key mechanisms behind the therapeutic potential of LSD. How so? Well, by disrupting those rigid patterns of thought in the default mode network, LSD might create an opening for new insights and perspectives to emerge.
Oh, I see. It's like loosening the grip of that autopilot mode,
Yeah,
allowing for more flexible and creative thinking.
precisely. But it's important to remember that even though these experiences can be incredibly profound and even transformative, they can also be challenging.
You mean like having a bad trip?
Well, it can be more than just a bad trip. For some people, especially those who might be more vulnerable, these experiences can be frightening, disorienting, or even trigger underlying mental health issues.
So it sounds like having the right support and preparation is crucial for navigating those intense experiences.
Absolutely. And it's not just about the immediate experience, it's also about the integration afterward. How do we make sense of these profound shifts in perception and integrate them into our lives in a healthy way?
Right. It's not just about having a cool experience. It's about using those insights for growth and healing.
Yeah.
And that brings us back to the idea of set and setting, right?
It does. Having a supportive environment and a skilled therapist to guide you through the process can make a huge difference in how you process and integrate those experiences.
Okay, so set and setting are clearly important for all psychedelics. But going back to safety, you mentioned earlier that LSD doesn't seem to have the same impact on body temperature or the cardiovascular system as MDMA.
Right. LSD doesn't cause that same kind of massive surge in serotonin or glutamate that we see with MDMA, so there's less concern about those immediate physical risks.
Okay, so the mechanisms are different. But what about neurotoxicity? You talked about the potential for that with MDMA. Is that a concern with LSD as well?
It's a good question. The research on LSD and neurotoxicity is a bit more complex.
Okay.
Unlike MDMA, LSD doesn't directly cause those huge spikes in serotonin and glutamate, which is a key distinction when it comes to neurotoxicity.
I see. So the way it interacts with the brain is just different.
Exactly. But even with a substance like LSD, which has a relatively low risk of physical harm, there are still psychological risks to consider.
Like having a difficult experience that could be psychologically damaging.
Exactly. And that's why the role of a skilled therapist or guide is so crucial, especially for people who might be more susceptible to those kinds of challenges.
So it really comes back to that idea of personalized medicine. Everyone responds to these substances differently.
Absolutely. And speaking of individual responses, we talked about how genetics can play a role in how people react to MDMA. Well, it turns out that genetics can also influence responses to other psychedelics, like LSD.
Really? So how does that work? Are there certain genes that make people more sensitive to the effects of LSD?
There's a growing body of research looking into that. Scientists are trying to identify specific genetic markers that could help predict how someone might respond to LSD or other psychedelics.
That's fascinating. So it's like personalized medicine for psychedelic therapy.
Mm,
You could potentially get your genes tested to see how you might react to a particular substance.
that's the idea. And this kind of research could revolutionize how we approach psychedelic therapy in the future, leading to more tailored and safer experiences for everyone.
It's pretty amazing to think about how far we've come in our understanding of these substances.
It is. And it's not just about the cutting edge science. There's a whole fascinating historical side to all of this, too. For example, did you know that scientists initially thought LSD worked by mimicking serotonin?
Really? I thought we just talked about how it actually binds to a specific serotonin receptor.
You're right, but in the early days of LSD research, scientists didn't even know there were different types of serotonin receptors. They thought LSD was basically just acting like serotonin itself.
So they were working with a very different picture of the brain back then.
Exactly. It wasn't until later that they discovered LSD primarily targeted a specific subtype of serotonin receptor, the 5-HT2A receptor, and that discovery really changed everything.
It makes you wonder what other mysteries are still out there waiting to be uncovered.
Oh, I'm sure there are plenty. One area that's particularly interesting to me is the long-term impact of psychedelic use on brain function. We touched on this earlier, but there's still so much we don't know.
Yeah, like what are the lasting effects of these experiences, especially on neuroplasticity, the brain's ability to change and adapt?
Right, and that's a question with huge implications, not just for understanding the safety of psychedelics, but also for potentially harnessing their therapeutic power.
Well, back then, scientists were really just starting to unravel the mysteries of the brain. They knew LSD was a powerful substance, but they didn't have the tools we have today to really understand how it worked on a molecular level.
So it's all kind of a big puzzle.
Exactly. And they were trying to fit the pieces together with limited information. They knew LSD had these profound effects on perception and consciousness.
Right.
And they knew serotonin was involved in mood, sleep, all sorts of important functions. So it seemed logical to assume that LSD was somehow mimicking serotonin's actions in the brain. Okay, so that was their initial hypothesis. But then how did they figure out that it wasn't quite that simple?
Well, as research progressed, scientists started noticing that LSD didn't quite behave like they expected if it were just mimicking serotonin.
Oh, how so?
They were seeing effects that couldn't be explained by simply increasing serotonin levels. LSD seemed to be doing something more specific, more targeted.
I see. So what was the turning point? When did they finally discover this 5-HT2A receptor and its role in all of this?
Well, a lot of different researchers were working on this puzzle, but a major breakthrough came in the 1980s. Scientists discovered this specific subtype of serotonin receptor, the 5-HT2A receptor, and they found that LSD had a strong affinity for it.
So it's like a lock and key. LSD was the key that fit perfectly into this specific receptor lock.
Exactly, and that discovery really changed the whole game. It explained why LSD had such unique effects compared to other drugs that affect serotonin, and it opened up a whole new avenue of research into how these psychedelic substances actually work in the brain.
And from there, the research on psychedelics just exploded.
Right, it did. And it's still going strong today. We're learning so much about how these substances affect brain function, behavior, and even the very nature of consciousness.
It's pretty mind-blowing, really. And speaking of mind-blowing, you mentioned earlier that one of those exciting areas of research is the long-term impact of psychedelics on the brain.
Right, and one aspect of that is neuroplasticity, the brain's amazing ability to change and adapt throughout our lives.
Yeah, the brain's not static. It's constantly rewiring itself.
Exactly. And there's growing evidence that psychedelics, especially those that activate the 5-HT2A receptor, might actually enhance neuroplasticity.
So it's like they're giving the brain a boost, making it more adaptable and flexible.
That's the idea. Some studies have shown that psychedelics can actually promote the growth of new neurons and the formation of new synapses, those connections between brain cells.
Wow, that's pretty incredible. And how might this relate to the therapeutic potential of psychedelics? I mean, why is this increased neuroplasticity a good thing?
Well, think about it this way. Many mental health conditions, like depression, anxiety, or addiction, involve these really rigid patterns of thinking and behavior,
Okay.
and sometimes even structural changes in the brain.
I see where you're going with this. So psychedelics, by enhancing neuroplasticity, might help to break those rigid patterns and create new, healthier pathways in the brain.
Exactly. It's like they're helping the brain to unlearn those unhealthy patterns and create a fresh start.
So it's not just about the immediate psychedelic experience. It's about the long-term changes that these substances might induce in the brain. That's pretty revolutionary, actually.
It is, but it's important to remember that this is still an area of active research. We need more studies, especially long-term studies, to really understand the full implications of psychedelics on neuroplasticity.
Right, and as we discussed earlier, there are also concerns about potential negative effects on cognitive function, especially with long-term or heavy use. It seems like there's still a lot we don't know about these substances.
Absolutely. It's important to be both excited about the potential of psychedelics and cautious about the potential risks.
A balanced perspective is key. Well, this has been an incredible deep dive. Thanks for walking me through all of this.
It's my pleasure.
I feel like I have a much deeper understanding of psychedelic safety now, from those tiny serotonin receptors all the way up to the big picture of brain function and neuroplasticity.
And the journey's just beginning. There's so much more to discover about these fascinating substances.
So true. Okay, everyone, we've reached the end of our deep dive into the safety and toxicology of psychedelics.
We've covered a lot of ground today, from the molecular mechanisms of action to the importance of set and setting, and even the long-term impact of these substances on the brain.
But, as always, there's more to explore. Here's one final thought to keep you pondering. We talked about MDMA's effects on body temperature and the need for careful monitoring in clinical settings.
Right.
But what about the long-term impacts on the body's ability to regulate temperature? Could repeated use, even in a therapeutic context, lead to lasting changes in how the body maintains its internal thermostat?
It's a question that deserves more attention as psychedelic therapies become more widespread.
Absolutely. Until next time, keep those minds curious and stay informed.
And happy trails, everyone!